Problem number 5 on 27A, pretty straightforward area under curve revolving type problem. So we got two curves, y equals x e to the x squared, the other one's y equals negative 2x, and that vertical line x equals 1. I just put in these points because we're going to need them later. So this point of intersection right here is 1, negative 2. Just plug 1 of that. Plug 1 of this, you get 1e there. The first question was to just find the area of the shape. So the area is just drawing little rectangles here. We're going to need them in the next one anyway. Here's top curve minus bottom curve, right? So the top curve is x e to the x squared minus negative 2x. This takes a little u substitution here. That one we can just integrate. The integral of 2x is just x squared. We do a little u sub, which you can follow on there. Pretty straightforward. You get 1/2 e to the x squared. We're integrating this thing from 0 to 1. You can see my work there. It's 1/2 e plus 1/2. Second question says, right, but don't evaluate integral expression that gives the volume of the solid when we revolve it around y equals negative 2. So that's down here. So this is going to be a washer method, pi, times the outside radius, which goes from that point of the rectangle all the way down to there. So that's that top curve, x e to the x squared, minus that curve, which is negative 2, minus the inside radius squared. This is the inside radius, which is the bottom curve, negative 2x minus negative 2 squared. They didn't ask us to actually integrate it, so we're done with that one. And the last question says, write, but don't evaluate an expression involving one variable that gives the perimeter of R. So now we're looking for perimeter. So perimeter is arc length. This is a curve. These are just straight lines, so I can figure out those distances. But arc length, you might remember, hopefully, is 1 plus the derivative squared. So integrating from 0 to 1, I'm trying to find that little length there. 1 plus, this is the derivative of my original function, derivative of the first, which is 1, times the second, plus the derivative of the second, e to the x squared times 2x times the first. So that's the arc length of that. And now I just need that and that. So this is just a vertical line. So I just need the length of it, right? Which is that length, which is e, and that length, which is 2. So that's the e plus 2 to add to that. And then I just need the length of that one, which is a little Pythagorean theorem. That length is 1, that length is 2. 2 squared plus 1 squared is 5. So square root of 5 for them. Pretty straightforward, good kind of combination of questions. Again, all of a sudden they got an arc length tossed into an integral problem.